In May 2019, the new legislation for tunnel safety will be put into place. From that moment in time, the Maastunnel in Rotterdam has to comply with multiple safety requirements. One of the safety measures is the AFM system. The Adaptive Flow Management System has three main objectives: to ensure a speed of at least 15 km per hour inside the tunnel. In case of fire, the air ventilation system circulates the fumes in the direction of the traffic flow. The smoke and fumes should not flow faster than the traffic. To ensure that traffic can always exit the tunnel in case of emergency, the vehicles that drive out of the tunnel require free space on the road, such that no queue can build up that reaches inside the tunnel, in order to support the manual operation of the tunnel. AFM supports tunnel operations in cases of emergency and in exceptional situations, such as vehicle height alarms, vehicle breakdowns, or urgent transports towards the hospital. The system detects the traffic situation automatically and controls the traffic lights automatically. In doing this, the system takes livability, traffic safety, public transport, and vulnerable road users into account. The system does not determine if the tunnel should be closed. AFM does anticipate traffic network conditions. With precautionary control, AFM distributes traffic flows over the whole network surrounding the tunnel. This network reaches from the motorway A20 in the north down to the motorway A15 in the south. Also, every important east-west connection is included. Here's an example. Multiple problem situations have been determined on which AFM acts. One of these situations is insufficient space in case of emergency. AFM monitors the amount of traffic and available space downstream of the tunnel continuously. To this end, it uses data from detector loops and radar sensors. Subsequently, AFM checks how much space is available to store traffic in case of an emergency. If this space threatens to be too small, then the system indicates the problem situation, insufficient space in case of emergency. Next, AFM decides at which location and in which direction it will create a solution, which in this case is downstream of the tunnel. The first signalized junction after the tunnel receives the function master. It provides less green time to traffic that conflicts with traffic from the tunnel, and it provides more green time to traffic from the tunnel. This results in more space for traffic inside the tunnel. Because this results in more traffic from the tunnel, a so-called guard ensures that no long queues develop downstream. The guard continuously checks the amount of traffic that drives from one road to another and ensures that more green time is provided. This allows all additional traffic in the longer queues to pass. If the first master cannot create enough space in the tunnel, then the system also takes countermeasures in front of the tunnel. Now, the signalized junction in front of the tunnel is assigned as the second master. This holds vehicles by assigning less green time to traffic towards the tunnel. Since queues can grow faster in this scenario, the master receives support from other signalized junctions. These decide how much green time will be provided to traffic towards the second master. In this way, the traffic flow is reduced in this direction. AFM coordinates the usage and availability of space on the road to hold vehicles, and holds vehicles only in case of a problem situation. By doing so, traffic is distributed evenly and gradually over the whole network. This keeps the network flowing, reduces congestion, and avoids unsafe situations inside the tunnel. Want to know more about the Maastunnel? Check out www.rotterdam.nl/Maastunnel.